Hi, today we'll be CSSing something inspired by this animation where we're going to approximate those curves with dots that are going to get smaller as they go inwards, but for now I should stop talking and get to coding. We are going to start with a number of rings, a number of hexagon rings, let's say 6. We're going to bump this up later, but for now let's leave it there. Then we're going to have a number of segments or edges per each ring, so also 6 because we have hexagons. Then we're going to have a number of balls per segment, let's say also 6. 6 times 6 times 6 gives us 216, so quite a lot already. Let's not make it even bigger for now. Then we're going to compute a total number of balls per each ring. This is going to be the number of segments per ring times the number of balls per segment. Then we're going to get the total number of balls for our demo, which is going to be the number of rings times the number of balls per ring, which we've computed earlier. Everything is going to be within the body, so we're going to have, while Q gets decremented and is still positive, we create our ball elements. Now the next step is going to be put something on the screen, even if ugly. We're going to start by setting display grid on the body. We're going to set a radius for our ball elements, let's say something like this. We're going to tweak it later. Then for our ball elements, we are going to set padding to the radius, background. We're going to set border radius 50%, so we round the corners. You can see how they're ugly and stretched, so we're going to set place self to center. The default is stretch, and now they're nice and round in the middle, but we want them all stacked one on top of the other. So we're going to place them all in the same cell at the intersection between the first row and the first column. And if I could type, that would be great. First row, first column. Okay. Now you can see how they only seem to be in the middle horizontally, and that's because at this point the body still picks the height of its content, which is basically that stack of balls. So let's explicitly set the height of the body to the full viewport height. And you can see how now in the middle, but we have that ugly scroll bar, which is caused by a margin around the body. So if we zero that, we get rid of the scroll bar. Of course, we can also go just full nuclear, overflow hidden. And before we move on to setting a few more styles, both in a style attribute on the body and in a style element where we're going to set indices and stuff, let's also set a background here so we can be done. Not quite black, but still pretty dark. And I suppose we can make this a red, just so that it contrasts more. Anyway, we're going to change it later. So here in a style attribute on the body, we are going to pass the number of rings, segments, and balls. We're going to pass them to the CSS as custom properties. So the number of rings, okay, and the same thing for the number of segments and the number of balls. Okay. And then we are going to have the number of balls. Now, one more thing I'm going to want to set here, but let me show you on a figure. So you can see how here we have a hexagon and we have two circles. One circle that touches this hexagon in the middle of each edge, at one point in the middle of each edge. This is called the in circle, and its radius is called the in radius. Okay, and then we have this outer circle which passes through the vertices of our hexagon, right? This is the circumcircle, and its radius is the circumradius. And here we have a right triangle formed by the in radius, the circumradius, and half of one edge, right? There we have 90 degrees. Now, that being a 90-degree angle means that the tangent of this small angle right here, which is half the central angle corresponding to one edge, right? So the tangent of this angle is half the edge over the in radius. Now from here we can compute the in radius as being half the edge over the tangent of this angle. But this angle is half of this one, which we can compute as being 360 degrees, a full circle, or 2 pi, divided by the number of edges, which is, we've called the number of segments in our demo, okay? So, and then we're going to want half of that. So 360 divided by the number of segments, or 2 pi divided by the number of segments, then further divided by pi. That's going to give us pi over the number of segments. So we want a tangent of that. So we can later get the in radius, because we know the edge. The edge is going to be made up of the balls set one next to another. And we have n balls, right? So the number of balls times the diameter of a ball gives us the edge length. And the diameter, we know it because we know the radius. So the diameter is twice the radius. That's how we're going to compute the in radius from that tangent. So the tangent of pi over the number of segments, and we don't want a lot of decimals, so we're going to limit the number of decimals to, let's say, 3, and we're going to want this to be a number, not a string. So like that. Then we're going to have a style element, which, by the way, is a sibling of the ball elements, which means that it's going to mess up the nth child index for the ball elements. So we're going to use nth of type. Let's first set the ring indices. For let I going from 0 all the way up to the number of rings, then increment this I. Now we have p balls per ring, and we're going to have p balls on the innermost ring, p balls on the second ring, p balls on the third ring, right? So the number of balls on the previous rings is going to be the ring index I times p. So for the first ring, which has index 0, this number is going to be 0, because we don't have any balls on any previous rings, because we don't have any previous rings, right? For the second one, which has I, the index 1, we're going to have p balls, those on the first ring, okay? So let's put that into CSS, ball nth of type, n plus, so after all the balls on the previous rings, which is I times p, plus 1, because the nth of type index is 1 based as opposed to loop index, which is 0 based. And here we're going to have the ring index set to the loop index, right? And then we're going to have something similar for the segments. Is going to be a bit more complicated, so leave it there for now. But for the balls, we go like this: 0, 1, 2, 3, blah blah, 0, 1, 2, 3 for the next segment, and so on for every ring. So every n balls, and here we're going to have just I, and we're going to set the ball index to k. And here it's a bit more complex, because the segment, let's say the top segment, has the same index for the first ring, for the second ring, and so on, right? So a single selector doesn't suffice. We need a list of n rings selectors. So we are going to start by creating an empty array, and then we're going to loop through the rings, right, and push into this array. But of course we're going to need to change the index of this inner loop so we don't mess up things. So we are going to push to this array the number of balls on the previous rings, which we've said is, yeah, this index j times p. Now that we've done this, we are going to create our list of selectors from that array. So we are going to map this array, and if I could type, that would be great. So the current item is going to give us ball nth of type. This is going to be the lower limit So the first ball on the current segment, on the current ring, right? So here we're going to have n plus, and we're going to have plus 1, right? And then we're going to have an upper limit where we're going to have minus n, and we're not going to have that plus 1 anymore, right? So here we're going to have all the balls on the previous rings plus all the balls on the current ring on the previous segments. So that is going to be I times the number of balls. That means then here we are going to have something similar, except it's going to be I plus 1. Okay, and then finally we are going to set the segment index to the loop index. So this should do it. Let's see it. Compiled HTML. You can see how we have the ring indices up to there, and here we start the list of selectors with a lower limit and an upper limit. So 1 is the first index, 6 is the last one, okay, and then we move on to the second ring. This is going to be the first index, the lower limit, the upper limit, right, and then we have another item in the list, and they all have J0, and then finally at the end we're going to have the ball indices, right, every 6 balls. Okay, that looks fine. Let's move on here and set a transform. First up, we're going to have a rotation, which we're not going to see because that thing is round, but okay, the segment index J over the number of segments times 1 turn, 1 full turn, which is basically 360 degrees. Then we're going to have translate, and as I said earlier, we are going to compute this in radius as being half the edge. So the edge is the number of balls times their diameter. Half the edge is going to be the number of balls times their radius, because the radius is half the diameter. So the number of balls, and I have a dash there, times the radius, and then we need to divide that by the tangent. So it's going to look like that, and then we are going to have along each edge, but let's first compute the difference between the current index and half the number of balls. So the ball index, which is K, the ball index on the segment, minus half the number of balls. Right? So here we're going to have this difference times the diameter, which is twice the radius. Okay, but if we want a bit of space between them, then we are not going to use the actual ball radius. We're going to use a distance that's somewhat bigger than this radius. Let's say 1.5 times the radius. So we can use that here, like that, so they look nicely aligned. Now the next step is, let's say that this is a custom property, and we actually set scale 0.5 and then that position custom property, and we're going to want to have an animation. So let's set an animation duration, I don't know, something like 3 seconds, and we're going to have a set of keyframes, and if I could type that right, that would be great. Then we are going to have transform. Okay. Ease in out, infinite, alternate. Okay, and then we're going to want to have a delay that depends on the ring. So let's actually compute something like a ring progress. So this is going to be the ring index I over the number of rings. Right, so we are going to have calc times the animation duration. Let's say that we're going to subtract an integer, let's say something like 2. So this is negative. So all delays are negative, and the animation for all of them looks started from the very beginning. Now you can see how it's hard to distinguish between those. So we're going to set an HSL value. Let's say that is going to be something like calc 360 so that ring progress, and then we're going to have 85% for the saturation, 65% for the lightness. Doesn't really matter, just to see different colors. But as you can see here, they don't quite go around, you know, from one end of the hue scale to the other. Let me just show you. So they seem to go from around here, which is 180, and for about 120 to about 300, let's say like that. So that means we're going to have 180 plus 120, something like that. Right, then we're going to want to have a different delay that depends on the position with respect to the middle. Okay, so we're going to get that by getting the absolute value of that difference, and I explained the how behind it in an article, which is going to be linked in the description, as well as other resources. So let's get the absolute value. It's basically the maximum between this difference and its additive inverse, which is basically -1 times itself. So here we're going to have over the number of balls per edge. So let's see it. Looks more interesting, and it's going to look even more interesting if we make those balls slightly smaller and we increase the number of rings, the number of balls. Let's say that we're going to have something like 18 there. And you can see how it looks more interesting, but oh, sorry. It is getting out of sync, so let's refresh. Okay, now the animations aren't out of sync anymore, and you can see how it looks pretty nice. You get that flower-like animation, and I'm not going to tweak it any further. I'm going to leave it at this. I hope you've enjoyed this video, and if you like the work that I've been putting out since early 2012 and you want me to be able to do more in the future, please consider supporting it. You can do so by being a cool cat and becoming a patron on Patreon, or if monthly support is not your style, there's the option of a one-time donation, or you can make this stray cat happy with a gift of her wish list. Or you could at least share this to show the world what can be done with just CSS these days, because honestly, I think it's pretty damn cool. In any event, thanks for watching, and I'll see you next time. Bye!